weather files as previous.
This is the same weather file you used from last Monday.
Okay.
Last Monday is...
On this, yeah, last Monday afternoon. On tutorial file. And then IDF file is the same file you used on Monday, but without any modifications. So prior any modifications you made on Monday. So now we selected it. I will just save this project so we can open it later, and I will save it to the same location where our IDF file and weather file is, and I will call it G plus simlab .gep. And I'll open here the folder we are working in. So the RVI file, the third file we need. Can anyone recall what is required to define that file and specify that file? What the RVI file is at all? The third file which we need to set up the parametric project. The file where we store information about outputs we want to extract from our Energy Plus simulation.
CSV.
So do you remember when I was speaking previously, it is completely text file where we have to have first two lines precisely defined and the last line is 0. It finishes with 0. Does it sound familiar to you? And then in between those first two lines and the 0, we have to place outputs we want to have from Energy Plus. Sounds familiar. Because what does Energy Plus do? Energy Plus can generate a lot of outputs. So hundreds and hundreds different outputs, depending what you want to. So, but writing outputs to the hard drive increases simulation time. So there is somehow compensation for that. So what we want to do, we want to tell Energy Plus exactly which output we want to have saved from the whole pool of outputs possible to be calculated and generated by Energy Plus. And this limited number of outputs, which we defined somewhere in Energy Plus file, is going to be saved to file with extension ESO. So all outputs from Energy Plus simulations, we asked it to be generated, will be recorded in ESO file. However, that file is not easy to read. I mean, human readable, it's very difficult. So we need extra step to convert information saved in that particular file into some Excel file, CSV file, so we can easily see what the heading for each output, like heating requirements, cooling requirements, and we can see certain values if it is like hourly value or annual value or whatever. So that is exactly what the purpose of this file here, which we are going to create and select, is. It is to tell where all outputs are, file name where that outputs are going to be converted to, this CSV human readable file, and then list of outputs we want to extract from ESO file to CSV file. And then, because it is a plain text file, to create it, you can use any text editor you want. Or you can copy already existing RVI file from some of example folders and then modify it for your particular purpose. So in this particular case, I'll create it from scratch as empty text file. Mandatory, first two lines and to finish with 0. And last line is 0. So these are first two lines, e plus out.iso. That is the name of the file where Energy Plus saves outputs. Second line is e plus out.csv. That will be text, a spreadsheet file, which we can open in Excel and have a look into outputs. And then we have to finish with 0. So in this particular case, and save it, of course, and give it some name. So this is, let's call it outputs.rvi. RVI.
And why does it have to finish in 0?
Because by reading name of output variables we want to extract between those two lines, that tool has to know where to stop reading further. And 0 is somehow masked to tell it, don't read anything after this 0. Because in this particular file, when we step into optimization week after, we will write some other steps, like define our objectives, for example.
What's the name of the file?
You can give it whichever name you want, and the extension is RVI.
Sir, where is the... I'm trying to find the weather file. I can't find the weather file.
Well, it was on the Moodle.
Yeah, but where? In week 3, week 4, it's not there.
Week 4 tutorial files. I downloaded it.
And what's the extension?
EPW.
Is it under software installation or supporting files?
Supporting files.
No, is this fine?
Yeah.
It's only showing lecture.r.
No, week tutorial session. You see, the extension is RVI. RVI.
I want to download it. I want to
So you don't carry a knife?
You see this? By clicking here, you can open this file into internal G+ text editor, and then can I ask you what will be extracted as outputs, simulation outputs, by using this RVI file?
Oh,
Magic.
oh, we closed the notepad. We just
Yeah, you save the file and then open it here. So by having this definition, we actually didn't specify any particular output we want to be extracted from simulation. So what we have to do, we have to know what our simulation can generate, and then from that subset of potential outputs, select something and paste it here,
After the 0?
before the 0. 0 is when
It ends.
when it ends. So where can we find the list of outputs which can be generated in our particular simulation? So that is one of the objects of the file. So I will open this file, IDF file, as a text file, because it is a text file.
Sir, can I stop you 1 second, please? So in my output file, it just says welcome to JE+. The project contains, and then that's it.
So we'll go to the end of this file and try to look to some output variables or what we can find here. So we can see here that there are some outputs asked to be generated about mean air temperature, air conditioner, electricity building, electricity facility. These outputs we can see they are hourly, these are annual. And we in general, when we run parametric study, we want to have like one number per solution to give us some hints. So I will choose one of those two parameters to continue with and to ask to be generated with the parametric project. So the difference between electricity building and electricity facility is that electricity building doesn't take into account electricity consumed by air conditioning system, while electricity facility takes into account both electricity for lighting equipment plus electricity required by air conditioning system. So I'll pick up this one to as outputs we want to have. So I will just copy the name and paste it to the RVI file.
Note to Mr. File.
Before 0.
No.
is it including the comma?
Without comma. Without comma. So now we created and generated those 3 files. So now we want to add parameters to this tab. And then, if you remember from last time, we defined the parameters by giving it unique name, which is a P1 identifier, for example, for the first parameter. Description, whatever we want to help us to memorize what that parameter is about. Search tag is very important. And then we add some values, alternative values for that particular parameter. So what was the first parameter you would take into account on practical session on Monday?
The thickness.
Thickness. Okay. So that will be our first parameter. Description, wall thickness, search tag. The purpose of the search tag is to be placed somewhere within the energy plus input file. So alternative values defined here can be pasted to that particular location within the energy plus file and replacing the search tag. So for example, if we create 10 alternative values, that means there will be 10 simulations generated by GE+. Each of these simulations will have only single value assigned to it instead of search string, which will be placed somewhere here to represent wall thickness. So this search tag we can just call WT, like wall thickness. It's completely user-defined name. But
Is it-
now the question is where to place it.
Is it case sensitive?
I think it is. I think it is. Not 100% sure, but I think it is. So where were we changing wall thickness in idea file? Can someone remind me?
We did it in the wrong thing first.
Sorry?
First we did it in the wrong place, then we did it in the correct
Yes,
place.
yes. So can someone tell
Construction.
me where this place is?
Construction.
Sorry?
The wrong place was
construction.
wrong place was material.
So let's search for construction. Is it somewhere here? So where can I place wall thickness here?
Exterior wall.
Which one? Exterior wall. But where is the thickness? So I need some other object. It's not construction where I can place particular thickness of the wall. So it's material. But which material? Wall material. Okay, let's search for wall material now.
I'm not sure you have enough.
So it's this one.
Right.
So now, if we want to apply these alternative values, which we will define, we have to place this search tag instead of thickness here. So instead of 0.25, we will place our search tag.
Delete.
We can just copy and
When
paste.
this dies, you start recording.
Oh.
Yeah, and basically what we started with was an IDF
That's
file
what I
that was
mean when he
working.
does something.
Now when you make this change, it's an IDF file that is no longer working. But it is one that JE Plus can use it to produce multiple files, different ones that are working. So what you're telling now by using this tag within the IDF file is that this is a parameter to be replaced whenever the alternatives are being generated. Okay?
So-
yeah.
Shall we now define some alternative values? You remember these alternative values can be integer, double, or discrete. So discrete means you can type any text if you want to. It also can be defined through certain distributions, and you have it in slides from last lecture. So let's just start with a couple of alternative values. So what would be alternative values you want to use here? For example, for wall thickness in meters.
0.1,
0.1 and
0.15.
so those two. Okay. So we'll just define them. 0.15. So now you can see here those two values will be used for the parameter. We now have to continue developing our parametric project by adding another parameter, clicking here on the plus button, and that will be our parameter 2, which is conductivity, if I remember correctly from last time. Wall conductivity tag can be just C. So where are we going to place this search tag in our IDF file?
So do you manually type in those?
Here.
Yes.
Yeah, we manually type numbers.
Materials. Construction.
Shall we search for construction or maybe look somewhere within this material?
Oh, conductivity is right there.
Yeah. So last time we were replacing this value.
Yep.
So 0.80 something, 89, we will replace it with the search tag. And please tell me a couple of alternative values we want to use to conductivity in our parametric project. Just to mention, I forgot to mention, because it is 0.1 and 0.15, we have to switch value type from integer to double, because it has decimal place. That is it is very important. So for parameter 2, it is again going to be with the decimal places, so change it to double, and tell me a couple of alternative values that we are going to use.
0.5.
Okay, and second?
0.75.
0.5 and 0.75. Okay, so now we have two values. Let's add third one, and third one was lighting. Search tag can be capital L. If you remember, there was it is lighting intensity in this particular case. So we have to search again somewhere where to place search tag. So it should be somewhere here. So where would you place our search tag L within some of these lighting objects?
At each of the watts per
We
zone.
would change each of the watts. So each 12 in these 5 objects will be replaced with the search tag.
That isn't it watts per zone floor area? That's 12.
Yeah, sorry, watts per zone floor area.
I think I missed something. Why are we changing the values for the search tags?
Because we want to assign certain alternative values for our parameters.
Okay.
So, for example, if you default option is 12 for your lighting intensity, 12 watts per meter square.
Yeah.
But you are not 100% sure. It can be 8, it can be 16, it can be some number. So you can either do it manually, run simulation and see results, or place them here, all alternative values, and then tool is going to run it for you, and you will get all the results together. So we want to
We
test.
can place several values at the same time?
No, what does it do? It takes only single value per time. But because we are defining multiple parameters, it is going to do permutations among all of them and generate as much as simulations as is the number of permutations of these parameters. So if there are 2 parameters with 2 values each, that means it will create 4 simulations.
Okay, great.
Yeah.
Thank you.
And the previous one for the conductivity, you could value type as double.
This is why you should come to lectures.
Double.
That was it.
What's the difference between integer, double, and
Integer is when it is just a number, 1, 2, 5, 10. Double is with the decimal space, and discrete is, it can be text string, so you can type something like name of construction. Yeah. So that is the difference. So now we are going to replace all these 5 values with search tag. Else, so here. And the alternative values, let's say 10 and 15. In this case, it can stay integer because it is a fixed number. And the last one was heating set point.
So when do we choose discrete?
The discrete is...
Oh, text. It's text, you said.
When there is a text string. So for example, if we want to change the terrain, which is like city, urban, suburb, that is a text string. In that case, we will have to choose discrete. Heating set point, let's call it capital H. Where are we going to place heating set point in our file?
Thermostat.
Thermostat. Okay, let's search for thermostat. So instead of 22, we will place our search string. And which couple of alternative values we want to choose now?
18,
18 and
24.
24. Okay. So please don't forget to save these changes by clicking here. If you do not save them, Energy Plus is going to create all projects but with default values. So it is not going to assign parameter unless we change the file first. So that is important. So how many possible simulations we can generate now with G+? What is the total number of simulations with these 4 parameters?
16.
16, yes. And then by clicking on validate project, it should calculate it for you. It is not robust enough, but it is a good check that you didn't make any mistake with setting up your parameter values, maybe not closing a bracket or things like that. So by click on validate project, we got like 16 jobs identified. So now we did set up our parametric project. So step from here is to execute it, because that's why we created it in the first place. And then to be able to run project, we have to go to the execution tab. And then first, and the most important thing, is to check and link G Plus to Energy Plus executables located in the folder where you installed Energy Plus. If you did use default values, it will be on your root drive. If you didn't link it correctly, this will be red. So if G Plus cannot find executables, this field here will be in red letters. So to change it from red to black, you have to find executables on your computer, and they will be, if you use default options, on your root C2 dot. We also have to specify output folder where we want our outputs to be generated, because what does G Plus do? It goes through the list of parameters, taking single value from each list, paste it to the IDF file instead of strings within IDF file, save that file within subfolder within the output folder, launch simulation, generates results for that particular case, and do that for each possible option from the parametric project. So good advice is to keep outputs within the folder where your files are, because in that case you would have everything in the single folder. So I will just change this to the output folder within the folder where Office file is. So the easiest way to do that is just to have a dot in front of output folder. Dot means a relative path to the folder where the project file is, GEP file is. Because GEP file is in our folder where simple Office file is, that means it will create new subfolder named outputs and output, and then within that subfolder there will be many subfolders, each for each option from the parametric project. So there are some other options. For example, this for G Plus automatically finds how many available processors you have on your computer. If you use them all, keep the maximum number, that means all available processing power will be used to run Energy Plus simulations. In this particular case, 4 simulations will be run in parallel. But that means you can't do anything else with your computer. It will be very difficult to go on the internet, because all processing power will be used by Energy Plus. So if you are planning to run simulations and use computer for some other tasks at the same time, reduce this number to 3 or 2 or whichever number you want, but that means it will take much longer to complete the whole parametric project. There are some options here about random sampling, but in this particular case, because we only have 16 simulations, we are going to execute them all by keeping all jobs and clicking on Start Simulation button. So you can see here, now we have some sort of the console window when it does say what's going on with our parametric project. So we can see there are these 4 simulations running at the moment, and how many are yet to be started to be simulated. Same information can be found here. Completed 4. At the moment, 4 of them are running. In the queue, there are 8 of them, so we can follow the progress of our simulations here. You can also reduce the processing power by using this slider here, sliding from 4 to 3 or to 2. It will apply that. And then once these simulations are completed, you can go and have a look into our summary outputs. So there should be a list file created with outputs from all 16 simulations in a single file.
Why is it so slow?
Because the model is not fast.
So it's not the computer. The
Oh,
computer
mine's
could
not,
handle it.
because it's i7.
Yeah, mine is i7 as well, but you might have a multiple 8 cores, no?
No,
Or maybe it's just the way it's programmed, right?
It's quite old, right?
It's not about the program. This is literally about the computing power of your computer. So older computers will be slower, newer computers will be faster. It is a direct correlation between type of the processor and your computer hardware. So mine is not particularly fast. It's decent, but it's not the fastest laptop in the world. So they are completed. We can close this task and then have a look into outputs. Outputs can be accessed in 2 ways. You can go here from the drop-down menu and go to the View Results tab, or you can just manually go to the folder where we defined our output folder is going to be. So see here, there is a list of 16 folders. Each of them contains a single Energy Plus simulation with a unique set of assigned parameters. There is an all combined result table, important for us. Runtimes is also important because this table here holds information about the success of our simulation. So if some of our simulation terminates because of any reason, we would be able to identify which run is that and then go to a particular folder